due to aging and other reasons, if zinc pouring is not proper and problems we will see now, joint will be in distress state and it may be over. And since it is used in Maharashtra, it may be case of dams in other states also. That's why this topic is very much important. Basically, purpose I found that to accommodate erection deviations of components for zinc pouring. Otherwise, there may not be any other reason for using this zinc pouring. And erection sequence is as usual. We first install anchor edges, anchor girder, then running bracket, end ups, horizontal girders, and skin plates. And lastly, we pour the zinc in between that 8 to 12 mm gap. And today's tie skirts are tightened. Here is a brief layout of anchor girder. And figure B and C shows the girder and tunnel bracket actual photo. Here in this yellow color, this portion is zinc pouring. This one is anchor girder, and this grey color is a bracket. This is your tunnel pin, and this portion we have filled with zinc. And this shows that the entire water load comes to zinc via bracket, and from there on it goes to anchor girder and piers. That's why this component is very much important, and what is going on we will see now. The property we may leave it because zinc is a much softer material than other materials. Your bracket is cast steel and girders are fabricated materials, structural steel fabricated section. That's why zinc is a very weak and fragile. That's why it makes the joint very fragile. Initiation of problems. Problem initiates from manufacturing stage itself, and it go on compounding in use. Here we can see theoretical failure modes of anchor girder and tunnel bracket joint could be compression, direct shear, tension failure, buckling failure, or a failure due to wrestling failures due to abrasions or torsion, etc. Now we will go next. This figure E. This is actual photo. This joint is prepared for zinc filling. Everything is in place. Erection is almost complete, and last step is zinc filling, and these guys are filling zinc on site. Actual filling process. If you see it, filling there is no other way. That's why we have to fill it in a very crude manner, and then all of the casting process deficiencies will crop up in this joint. What happens we will see now. The different dams and gates deficiencies noticed for zinc pouring from time to time. I have noticed these I classified in 6 categories. First one is cavities and pores in initial filling. This comes due to casting process. Then cracking of zinc pouring, removal of shards, small pieces or big pieces. Then third group comes not removal of weldments used at the time of zinc filling. Joint is made permanent by welding pieces, bars, strips, like that. Fourth is loosening of zinc pouring sheet. Fifth one is gap between anchor girder and tuning bracket due to various reasons. And last one, sixth, is no use of zinc pouring. See, you will see pictures. Cavities and pores in initial filling. As we have seen, the zinc process. The process is rather crude. That's why all the casting defects will come in this pouring process, and it will remain there forever the life of joint. We cannot ascertain the uniform filling of molten metal at the time of filling. That's why all inherent deficiencies crop up. You see here some pictures I have put. This one is Kharagpur Dam joint. Here is this pier side face. Here entire length is not filled. Some here gaps are also there. The filling is not complete. Actually, it should be a very fine filling. So then and then we can transmit the loads effectively to the gutter. This one is lower Varda. Here you see, here is also a gap, and that gap goes to down. These two photos are from Mira Devgar Dam. Here you see the bracket is not seated properly. Top portion is filled, but from downside see you downside portion there are gaps. Molten metal zinc is not reached there. Likewise, there are number of deficiencies in the process. Mostly of these deficiencies crop up at the time of filling only, and if you are not inspecting properly and tackling it, then it